Here are your notes on today's IP page. It's called Lewis dot structures. Please title your IP page. And the essential question for today is, what is a Lewis dot structure and what does it tell us about atomic structure? Take a minute to set up your notes, pause the video for as long as you need. So a while ago, a guy with the last name Lewis came up with this way of showing how many valence electrons each atom has. So we call it the Lewis dot structure after the guy who basically invented this method. Please take this note that this is the purpose of the Lewis dot structure is to show how many valence electrons an atom has. As a reminder, a valence electron is the electron that's on the outermost shell of that atom. It's a diagram that represents the element symbol and a really simple dot representing the valence electrons. So if we were to take a look at a sodium atom, a Bohr diagram of the sodium atom, we would notice that the sodium has 11 electrons because it has 11 protons. And if it's electrically neutral, the protons and electrons are the same. So we put 2 electrons on the first shell, and now that first shell is full. We put 8 electrons on the second shell, and now that shell is full. 2 plus 8 is 10, but there's 11 electrons, so we have 1 electron on the next shell, and that 1 electron on the outermost shell is the valence electron. So if we were to draw the Lewis dot structure, it would look like the symbol for sodium and 1 dot representing that 1 valence electron. So we're going to use this symbol. Make sure this is in your notes. There is no element with a symbol E, but we're going to use this generic symbol, a capital E, to represent whatever element symbol. If we were to show that an element had 1 valence electron, we would put 1 dot on the right. If an element has 2 valence electrons, then we would put a second dot on the top and continue in this way going counterclockwise. So if an atom has 4 valence electrons, we would have 1, 2, 3, 4 dots. If an atom has 5 valence electrons, the 5th dot would go here, 6th here, 7th, and 8 valence electrons. So basically we put them, as we're drawing them, we would draw them in that pattern. This is on the Opie side for today's work. So I want to show you what this would look like. This is going to be really closely related to the Bohr diagrams that you guys already did. So you're really going to be going back and forth between your IP, taking notes, to this OP page, and then referring back to this page where you already drew the Bohr diagrams, because really it's all related to each other. So if you look at this page for the Bohr diagrams, we'll start with hydrogen, and since hydrogen has only 1 electron, then it only has 1 valence electron. So here's how we would draw that. We would draw that 1 valence electron on hydrogen, starting with the first one on the right, 1 valence electron. Let's go over to helium. Helium has 2 electrons on its outermost shell. It only has 2 electrons, but since they're on the outside, then helium has 2 valence electrons, and we would draw it 1 and 2. Let's take a look at lithium. Lithium has 3 electrons, but that 3rd electron has gone on the second shell, and so lithium also has 1 valence electron. So we would draw a 1 right there. Let's go to beryllium. Beryllium has 4 electrons total, 1, 2 on the first shell, 3 and 4 on the second shell. So I'm only looking at the valence electrons. There are 2 electrons on the outermost shell. So I would do the Lewis dot structure like this, 1 and 2. We're skipping that whole section in the middle. So basically, go back to your IP page and continue to take some notes. This whole section right here in the middle is called the transition metals, and they get a little bit weird when we're talking about valence electrons. But here's something that I want you to start noticing. As we look at the valence electrons and the column of the periodic table, this needs to go in your notes on IP. Every single element in column number 1 has 1 valence electron. Every single element in column number 2 has 2 valence electrons. Skipping this middle section of transition metals, start with boron, the element that has atomic number 5. So here's boron. Boron has 5 electrons. 1, 2 on the first shell, 3, 4, 5. So here's how I would draw boron. 1, 2, 3 valence electrons. Everything in this column right here is going to have 3 valence electrons. 4, 5, 6. Everything in this column has 7 valence electrons. And everything in here has 8 valence electrons except for helium because it only has 2 electrons. This is a pattern that you're going to notice in the periodic table, both in your Lewis dot structure page and on the Bohr diagram model page. That elements that are in a column have something in common. That's why we put them all in a column together on the periodic table. So a lot of times I have students that ask questions like, why does this matter to me? Well, this is why this is important. Valence electrons are essential to all life on Earth. For example, hydrogen, we already talked about it. Hydrogen has 1 valence electron, right? Well, oxygen has, if we were to draw the Lewis dot structure for oxygen, oxygen has 1, 2, 3, 4, 5, 6 valence electrons. So here's the deal. Oxygen can hold 2 more electrons. It only has 6 valence electrons, so on its outermost shell, it still wants to get 2 more. So oxygen will go looking for another element, hint, hint, hydrogen, to get another electron from. Well, even if it bonds with 1 hydrogen atom, it still can hold 1 more valence electron. So oxygen will go looking for another hydrogen atom to bond with and get its electron shell full. So the reason why valence electrons are essential to all life on Earth is because this is how water molecules get created. Water molecules get created because each atom wants to have a full valence shell, and it will go looking for other atoms that have an electron to give in order to create this molecule. All right, so these are all of the notes. So you're going to go back and forth between the OP and the IP side. Make sure that you have, I'm going to go all the way back, sorry. Make sure you have questions. Make sure you highlight your notes, and make sure you answer the essential question. Going back to the beginning, what is a Lewis dot structure, and what does it tell us about the atom's structure?